Okay, in this lesson, this is actually the last lesson in a three-part video on the turning effect of a force. So let's dive into the content first. So in the previous two lessons, we have talked about what is the moment of force and how to find it, and what is the principle of moment, as well as deal with some basic questions on principle of moment. So in this particular lesson, we are going to deal with a little bit harder questions on principle of moments. So let's recap on the definition of the principle of moments. It states that when the body is in equilibrium, the sum of the clockwise moment about the pivot is equal to the sum of the anticlockwise moment about the same pivot. So you got to really memorize and understand this principle in order to apply it properly. All right. So moving on, I also want to explain a particular definition that is very important, which is what is the center of gravity, because in some questions they do not give you the force. One of the force that they do not give you is the weight. You have to find out where does the weight of the body acts. If you don't know, you may end up missing one of the forces acting in the body in the moment question. All right, so what is center of gravity? It's a point through which the whole weight of an object appears to act for any orientation of the object. So in these three diagrams below, there are actually cases where the object is regular. So the center of gravity is obviously in the center. Okay, easy way to find the center of gravity is to draw the axis of symmetry, all right, which is two lines that cuts any line that cuts the object into two equal parts. All right, so in the first case, the axis of symmetry will be as shown. So the center of gravity will be the point of intersection. So at that point, you draw an arrow down with the weight, and you have already located exactly where the force acts and in what direction, which is always vertically downwards. All right. So in the second case, similarly, axis of symmetry and the weight vertically downwards. For a circle, you just simply have to define it as the point in the center. So in all three cases, do be reminded that this is actually your CG. All right, this is actually your CG. Okay, so CG as in center of gravity. So let's move on. So these are the examples where you need to know where to put your CG. So this question asks, a 300 gram walking stick is balanced by a 100 gram mass at 15 cm from a pivot. How far is the center of gravity of the walking stick? So obviously there are two forces acting on the walking stick. The first force is the 100 gram mass, and obviously it is trying to balance the other force, which is the weight. If you are not aware that the weight is acting here, then you will not be able to even start to do this question. So the first thing you need to do is to draw down the forces that are acting on the body. So the first one is the one that is acting through the block, which is the 100 gram mass, and the other one is the weight of the walking stick. So what you do is you locate the center of gravity of the 100 gram mass and you draw an arrow down, and 100 gram is 1 Newton, okay, because 100 gram is 0.1 kg. All right, let me just write down here. 100 gram is 0.1 kg, and 0.1 kg is 1 Newton. All right, because 0.1 times 10 gives you 1 Newton. All right, similarly, 300 gram is 3 grams, and you're assuming that this is the CG. We don't know as it, we just assume this is the CG. So now you realize how important to know CG, because once you know the power of CG, you draw an arrow down. This is the point where it acts, and this is the point where the 3 Newton acts. So with this information, all right, you can solve. First of all, write down the statement. The clockwise moment will be 1 times 15, while the anti-clockwise moment is 3 times d. So the answer is 5 centimeter away from the pivot. Okay, So let's try the next question. Okay, can you find the value of F in order to balance it? So if you are given this kind of question where the diagram is not something that you are familiar with, which is a beam and a pivot, a easy way to make it more convenient for you is to redraw this diagram into the way that you know, which is a pivot and a beam. Alright, so if you redraw it, you realize that this diagram becomes a lot simpler. Alright, so obviously the clockwise moment will be this guy, 600 Newton, and the anti-clockwise moment will be F. Alright, so be careful, the anti-clockwise moment, the perpendicular distance is not 50 cm but 120 cm. Alright, let's try to calculate. Again, write down the statement. So the clockwise moment will be 600 times 70, and the clockwise moment will be F times 120. So the answer will be 350. Alright, in this particular question, they also ask a very thought-provoking question, that is, if the height of the handle is raised, will it be easier to lift the wheelbarrow? Okay, so I want you to think about it. Okay, so what do you think is the reason? You may want to pause the video for a while. Okay, so the answer should be there is no difference, because if you lift the force up, what happens is that the distance, perpendicular distance of the force from the pivot is not changed, because even if you lift it up, the perpendicular distance remains 120. So the answer is no, because the perpendicular distance to the pivot has not changed, so the force F required is the same, right? So that is the answer. Okay, let's move on. Now this question is actually an O-level question which appeared a few years ago. So this question asks you to find the minimum force F required to lift the leg up. So the first thing is that a lot of students cannot start the question because they do not know where is the pivot, or some students actually thought that the pivot is here, alright, at the joint, at the ankle. So you have to be very careful. You must think about this leg and this cast, alright. If this leg and this cast is supposed to be supported by this force here, obviously this force is preventing the leg from rotating. If this force breaks, the leg will swing down. If it is pulling too much, the leg will swing up. So it will swing about where? You will swing about this point. So the hip joint becomes your pivot, right? So if you can identify that the pivot is at the hip joint, you are already halfway to winning the battle. So again, similar to the previous question, you need to reduce this question to a pivot and a ruler so as to simplify it. So if you reduce this into this pivot and the ruler, you realize that it's actually a very simple diagram with two clockwise moment and one anti-clockwise moment. Again, be careful that this distance for F has to be the sum of all three. For 40 has to be the sum of these two. Well, for 80 is only for one. Alright. So the clockwise moment equal to anti-clockwise moment. If you have been careful about the distance, you will definitely arrive at the answer of 65 Newton. Alright, 65 Newton. Okay. So no issue about this. Now let's look at this question, which is your second last question. This is a very classical question that they always ask. Now in this case, you have two pivots. So how are you going to solve for it? Okay, one of the powerful thing about principle of moment is that you can take pivot at any point. That means you can take pivot at this point, or you can take pivot at this point. Now let's say I take pivot at point A. What will happen? If I take pivot at point A, alright, let's say this is the pivot. Alright, what happens is that FA, the force which is supporting the beam at A, will have a perpendicular distance of 0. When it has a perpendicular distance of 0, it has no moment. So when it has no moment, it does not participate in the calculation at all. So you can ignore the effect of FA if you are taking the pivot at A. So in actual fact, it's just simply FB, moment of FB, moment of 30,000 Newton, which is the weight of the beam, and the moment of the 6,000 Newton. Only these three, because FA has no moment, that's why it's not included in the calculation. Alright, so taking moment about A by principle of moment, clockwise moment go anti-clockwise moment, you realize that these two clockwise moments, 6,000 times 40 plus 30,000 times 60 is equal to FB times 120. There is no need to calculate FA. Alright, so using this information, you realize that FB is equal to 17,000 Newton. So how do you find FA? There are actually two ways. One way is you can take moment about B, and FB becomes no moment, similar to the first case. So when FB becomes no moment, you use the same method to find FA, but that will be a bit laborious. So I'm now proposing to you another method. Alright, now you know that when an object is in equilibrium, there will be no resultant moment. Do you know that when an object is in equilibrium, there is also no resultant force? Okay, no, the resultant force is 0. So if a resultant force is 0, that means that the vertical forces, these two, and the downward force, these two, must add up to 0. Okay, let me just remove all this first. These two forces, this one and this one, are vertical, and these two are downward. So these four forces must add up to 0, because there's no resultant force going up or down. So because of that, FA plus FB is equal to 30,000 plus 6,000. So FA will be 36,000, which is the sum of these two, minus FB, which is 17,000, you give you 19,000. Alright, if you want to verify whether this answer is correct, you can use the other method, which is take moment about B, to find FA. You will find that it is exactly the same answer. Alright, so this is a far more efficient way of finding FA. Alright, so now I'm going to move to the last question, which is this question. What is the minimum force F required to balance the horse? Alright, so the first thing you need to do is, again, this is a 10 kg rocking horse. So you need to know that the weight, that the force that this F is trying to counter is actually the weight of the horse. So obviously, you know this is a center of gravity. You need to draw a force down, which is your weight. So in this case, it is 100 Newton. Alright, I already have the animation, 100 Newton. Alright, so once you draw the force down and you know that this is 100 Newton, you have already found for yourself the two moments. One is the clockwise moment here, and the anti-clockwise moment here. Alright, and this will be your pivot, because this is the point of rotation of the horse. So if this is the point of rotation, the perpendicular distance of the 100 Newton will be A cm, while that of the F will be this perpendicular distance, which is 40 cm. Alright, I hope you can see the development of the question. So taking principal moment, 100 times 8 will give you F times 40. So because of that, your F is 20 Newton. So I hope that you can go back to any part of the question and try to view the lesson again, so that you have a better understanding, because I need to teach very fast in this video. You may need to go back and view again, So if you do not if you have any comments that you feel is important and relevant, you can actually comment in the blog, so that I could provide a better explanation for anything that you are not sure. Okay, so that's all for this 3-part lesson. Thank you and have a nice day.